So let's begin with the theoretical concept in computer science, or the theory of computation. So first we have the sets. As always, set is a collection of predefined objects, like set of all natural numbers, set of all real numbers, and so on. They may be finite set, they may be infinite set. So this fancy n denotes natural numbers, this fancy z denotes real numbers, and this phi denotes empty set, or half curly braces also denote empty set. Next we have the property or the operation of sets, that is union and intersection. Next we have complements of set S bar, and we have cross product of set S cross T, where T is the another set. Next, for n cross n, we can denote it like this: n of ni comma j for all n comma j greater than 1. Next we have is the tuples, and these are the tuples, and this you can say also sequence. And power of set, so number of subsets we can form is known as power of sets. So to power n, where n is the number of sets, n is the number of elements of the sets. Next we have Venn diagrams. So these are the basics of sets. Next we have is the functions. So it may be a single variable function x, where f maps d to r, where d is domain set and r is the range set. Array function, unary function, binary function, k-array function, there may be many. So in unary function we will be denoting by functional denotation will be f of a, in binary g of ab, in k-array h of a, b, c, d, and so on. So the prefix notation of this function f of a is minus a, and the infix notation of this function g of ab is a plus b. Next we have are the predicates. Predicates are something in which you have input domain and you guess bools as output, either true or false. So for example, p of x is predicate, either it is true or false. Like we have odd number, 4 is odd, no, so it is false, so it is a predicate. Next we have are the relations. Relations can be many, a cross n, n cross n relations, and domain can be anything, but the range is either true or false, or the bools. The properties of relations: it can be a reflexive relation, it can be a symmetric relation, it can be a transitive relation. Asymmetric, it can be asymmetric also. So for example, transitive relation is something like less than. If a is less than b and b is less than c, then you can imply that a is less than c. Okay, this is known as transitive relation, and symmetric relation and reflexive relation. So next we have is the in degree and the out degree. In a graph, the in degree is number of nodes coming in, means number of the edges directed into the node, and out degree is number of edges directed outside the node. Next we have the binary relation, or the directed graph. Like for example, we have a relation RAB is either true for all values of a and b. So there is a and b, so for every value in a there is a b which is true, so you can say it is directed towards b like this. This is the function notation, and this is the infix notation, a r b, infix notation. And then we are familiar with trees. Trees is a graph. Trees is a kind of graph with directed nodes with no cycles and no edges. And next we have is the directed asynchronous trees. acyclic trees, directed acyclic trees in which we cannot form a cycle. Directed acyclic graphs, so this is the root, the parent, so the trees in which the parents are sharded, so this can have two parents or the two roots. These are the two roots of this node, and you cannot form a cycle in this. This is directed like this. Next we have the strings. Strings is this finite set of sequence. It comprises of alphabets denoted by sigma, set of symbols. So sigma, set of symbols which are always a finite set, and epsilon is the empty string, and length of string is denoted by this mod. For example, W is a string srpta and mod W is phi. So the mod of epsilon will be 0 as it is an empty string. So let's take an example of string concatenation. Assume x is NIG and y is ER. So XY will be concatenation x cross y NIGO, and x power r is reverse of x, that will be x will be changed to GIN. So next thing is language. A set of string is called language. It can be finite or it can be infinite. So it can be a finite strings or it can be infinite string. The empty string is epsilon and the empty language is set of empty strings. So there is a difference. So language containing epsilon is not a empty language, but a language which is empty is empty means it is not containing any strings. So how to describe a language? We can describe a language by enumerating the strings like A, B, C, B, C and D, or else we can use regular expressions, or you can use context-free grammar like this. S maps is transformed to DT, and set notation is always there for us. Next we have the Boolean algebras: and, or, not, conjunction, disjunction, negation, exclusive or equality, implies, implication, and the distributive laws and the De Morgan's laws, and so on and so forth. Next we have the first order logic. In first order logic, for example, for all x is a man, x implies is mortal. Is man Socrates is mortal? Yeah. So it is a universal quantifier and existential quantifier. For all means for all x, and this is a statement, and for exist is a statement. So in this, only for one x it will be true, one or some x, and it should be for all x. Universe of objects, relations between the standard statements are true or false. Well formed formula, or the WFF. So this is the demonstration where for all x this is the predicates and these are the logical operations, and similarly it can be true for the functions. So there exist y, for all there exists x. This is a predicate and this is again a function, and again predicate, again a function, and this was the first order predicate logic statements. So next we have mathematical theorems. So theorem is a known to be true. Proof is a mathematical argument. Sometimes it is brief, sometimes it is elaborate. Lemmas are the proven statement, like in proved in isolation, part of larger proof. Corollary, a true statement, a theorem you can say, but it is a part of theorem derived from the main theorem. Next we have the conjunction, unproven, possibly true. If and only if statement, sufficient and necessary conditions. And we have proofs, three types, like proof by construction or the direct method, proofs by contradiction, and proofs by induction.